Everyone. So we're gonna use Trig today, like we did the last couple of days, to solve some application problems. We're gonna use it like we did yesterday, and we're gonna solve for missing sides and angles. Yesterday we specifically just solved for angles. Today we're gonna use Trig to solve for sides as well. Okay. So on the top part of your notes is a warm-up. This would be a good place to pause and see what you remember from yesterday. Okay. Alright, so assuming you're checking your answer, we can do Pythagorean theorem to find the missing side. So a squared plus b squared equals c squared. Alright, let's see. Alright, so take the square root to two decimal places, and AB is about 13.48, and then don't forget your units. Okay, so there's the length of the segment. Alright, now for angles like we did yesterday, I'm going to use the two sides that are here. And you're going to see that throughout the lesson today. I don't like to use the side that I just found, just because one, I rounded it, and two, what if it's wrong? Then the next part's going to be wrong. So I'm going to put theta here. Or actually, I'm not going to put theta, I'm sorry. I'm just going to use the letter A. So from this point right here, using these two sides, I can use tangent, since this is my opposite and this is my adjacent. So that's your TOA. Okay, so I'm going to set up my equation, and I'm going to say the tangent of angle A is equal to my opposite side over my adjacent side. Okay, like yesterday, if I want to figure out what the value of A is, I need to undo tangent. So to undo tangent, I do tangent inverse of that ratio 11 divided by 7.8. Okay, so that means that angle A is about, so if I do second, actually let me make sure this is in the right mode. Okay, I'm going to do second tangent 11 divided by 7.8. That tells me my angle is about 54.66 degrees, which then means I can find angle B by subtracting 90. So angle B is about 35.34 degrees. Okay, so that was just review from yesterday. Today we're going to do some of the same, so practice some more, but we're also going to use trig to find a side instead of just an angle. Alright. Number one says find the missing sides and angles. Alright, so if I know that this angle is 51, I can figure out this other angle, but I'm going to do it using this reference angle right here. So if I'm here, let's say I call this side that I don't know x, and this side that I don't know y. So given this angle, this is my opposite, this is my adjacent, and this is my hypotenuse. Okay, so notice we have two pieces of information. If I want to figure out x, I could use sine, because sine is my opposite and my hypotenuse, and I know two of those three things. Okay, so I could say sine of 51 equals my opposite side, which is x, over my hypotenuse, which is 10.6. And notice now I have an equation with x. I just have to figure out how to get x by itself. Okay, remember there's 1, 2, 3 things that I need, and as long as I have 2 out of the 3, I can solve. Okay, before I pick up my calculator and I solve this, I'm actually going to set up my other equation to solve for y. So if I'm at 51 degrees, and this is my adjacent and my hypotenuse, I can use cosine. So I can say the cosine of 51 degrees equals my adjacent side over my hypotenuse. Okay, you can think about this like we did in the last unit. Whenever you have x right here and you want to get rid of the denominator, this is division, so you multiply by 10.6. Or you can think about it like last unit, and you can think about it as a proportion, which just means then you would cross multiply. So x times 1 is x. 10.6 times sine of 51 is 10.6 times sine 51. Okay, notice that x is by itself, so all I have to do is put that in my calculator. I do the same thing over here. I can put this over 1 and cross multiply, or anytime you have a denominator, you're multiplying by the denominator. So this would give me 10.6 cosine 51 equals y. Okay, so I know that x is going to be about, and now notice that I have no inverse. Inverse is only used when we're finding an angle. We know the angle. So we're just going to put in our calculator 10.6 times sine of 51. Make sure you're getting the same thing. And we get that x is about 8.24. Okay, and then over here we get, let's see, we have 10.6, but now cosine of 51. And we get that y is about 6.67. Okay, so in terms of my triangle, x was BC, so I'm going to say that BC is about 8.24 meters. AB is about 6.67 meters. And I also need angle C, which has to be 30, equals 39 degrees. Okay, and then these would be my 3 unknowns that now I know. Okay, so let's try some more practice. Find the missing sides at angles, so same type of thing, but now instead of being given a side and an angle, we're given 2 sides like we had yesterday. Okay, so this would be a good place to pause and try this on your own since you had it for homework. Okay, so assuming you're checking your answer, I'm going to use this as my reference angle. Notice that from there, this is my opposite, this is my adjacent. You could have used B. That means that I need to use tangent. So I'm going to say the tangent of A equals my opposite side over my adjacent side, which is 16 root 5. Okay, this is where I get here, and I think, okay, well, if I need to undo tangent, then I'm going to do the tangent inverse of that ratio. That's what undoes tangent. Okay, so that means that angle A is going to be about, so let's see, tangent inverse, 18 divided by, and you guys need to make sure that you put this in parentheses for 16 square root of 5. Otherwise, your calculator will do 18 divided by 16, and then it will multiply by root 5. Okay, so make sure you got 26.71. And then degrees, that means that I can find angle B. So 90 minus 26.71, 63.29 degrees. So those are my 2 angles. Okay, I can figure out my third side by doing Pythagorean theorem. So let's see, we have 16 root 5. The whole thing is squared, plus my other leg squared, equals c squared. Okay, so 16 square root of 5. This whole thing squared. Just be careful with your parentheses. Plus 18 squared. Alright, I get 1604. Make sure you guys are doing this so you can check and make sure you're getting the same thing. So root. And I get that segment AB is about 40.05 Oops, and I have different units here. Let's just make this centimeters. And there we go. Right, so that was reviewed from yesterday. Alright, so flip it over. We're going to do some more of the last problem. Alright, find the missing sides and angles again. Let's see here. Okay, so you have a couple options here. If we know that this angle is 12.9, we can figure out this angle. Okay, I always like to do it just from the angle that we are given. That way, then, in case I subtract wrong or do something like that, you know, I'm avoiding that problem. So I'm going to label this as X. I'm going to label this as Y, just so I have some variable to use. Okay, from this angle, this is my opposite side, this is my adjacent side, and this is my hypotenuse. Okay, so when I think about what equation I can set up to find my X, I'm going to start with X. This is my opposite and my adjacent, so that means I'm going to have to use tangent. So I'm going to say the tangent of 12.9 degrees equals my opposite side, which I called X, over my adjacent side, which I called 17. Okay, now let's say I want to solve for Y. Well, then I'm using my hypotenuse and my adjacent, and cosine uses my adjacent and my hypotenuse. So I'm going to say the cosine of 12.9 degrees equals my adjacent side over my hypotenuse, which I called Y. Okay, so again, over here, anytime that we have a denominator, we're always multiplying by the denominator. You can also put this over 1 and cross multiply. Okay, when I multiply by 17, I get that X equals, because I just got X by itself, X equals 17 times tangent of 12.9, and then that's what I'll put in my calculator. Over here, notice that this is a little bit different. The Y is in the denominator. We want to make sure, and this is one of the most common mistakes, is that you guys see the 17 and then you want to multiply by 17. But that's not true because we're dividing by Y, so multiplying by 17 is not going to undo anything. So this might help to really make this a proportion and say, okay, this is over 1. So then when I cross multiply, I get 1 times 17, which is 17. And then I get Y times cosine of 12.9. So notice we didn't get Y by itself, but we did get rid of the fraction. And now that I got rid of the fraction, now I can get Y by itself by dividing by the cosine of 12.9. Divide both sides by the cosine of 12.9. And notice now I got Y by itself. Okay, so when I'm finding X, I'm going to do 17 tangent of 12.9. So put that in your calculator and check your answer. You should get that X is about 3.89. And then over here, I'm going to say now 17 divided by 3.89. Oops, it's not that. 17 divided by the cosine of 12.9. And then you get that Y is about 17.44. Okay, so notice that we multiplied when my X was in my, or when I had a number in my denominator, and over here I ended up dividing when I had my Y in my denominator. Okay, so just something to take note of. Alright, so now I can summarize everything. Let's see, I have that segment AB, which was X is about 3.89 inches. I have that segment CB is about 17.44 inches. And lastly, I have that angle B equals, let's see, 90 minus 12.9, so 77.1 degrees. Okay, and those were all the unknowns. So notice that by using trig, we can do a lot more than Pythagorean theorem could allow us to do, or even similarity. I only have one triangle, so I couldn't use similarity anyways, but a lot more options. I can be given a lot less. Okay? One other thing. Once I found X, and I found that it was 3.89, I could have used Pythagorean theorem and done a squared plus b squared equals c squared to find my hypotenuse. You can absolutely do that. Just know that when you do that, your answer of 17.44 wouldn't be the same. It's going to be close, like maybe 17.42, something like that. But trig ends up being a little bit more accurate than using Pythagorean theorem. They both, again, you're rounding. That's why your answer is going to be slightly different, but it's okay. So either or is fine. Just know that if you're checking your answer, it might vary slightly. Okay. All right. Number 4. The drawing below shows a ladder against a wall. How high on the wall does the ladder reach if the ladder is 14.62 feet long? So here's your ladder. Ladders are always the diagonal. It's always your hypotenuse. Since ladders won't lay across the ground, otherwise it wouldn't be a right triangle, and ladders won't lay vertically because then there's no right triangle and it wouldn't work. Okay. Then you can cross this off. You can do this. So it says how high on the wall. So that means that we're trying to find B. Okay. So the first thing you want to do is recognize the sides that you're given. So if you're given angle 20 right here, this means that this is my adjacent side and this is my hypotenuse. So with that information, I would be using cosine. Now I also have the option to say, well, if that's 20, then this has to be 70, which now means that this is my opposite and my hypotenuse, which then means I'd be using sine. So up to you what you want to do. Like I said, I like to just use what I'm given. That way I don't accidentally do some subtraction wrong or something like that. Okay, so I'm going to use cosine. So cosine of 20 degrees equals my adjacent side, which is letter B. You can use any variable you want, over my hypotenuse, which is 14.62. Okay, in order to get rid of the denominator, I multiply by 14.62 to both sides, and then that will give me 14.62 cosine of 20 equals B. Okay, got B by itself, so I just need to put it in the calculator. And I get that B is about, let's see, 13.74. What was this in feet? Yep. I'm going to say high. So the ladder can reach, so at an angle of 20 degrees, if the ladder is 14.62 feet, the ladder can reach 13.74 feet high. Okay. Notice if I wanted to, I could use Pythagorean theorem now to find CB. I could also set up another trig function. Usually I just use 2 trig functions because to me it's actually easier than Pythagorean theorem. And if I'm going to set up one, I might as well just set up the second one. Okay. Alright, so moving on. The height of the tree is 109 feet tall. So 109. The angle created with the ground and the rays of the sun. So notice this is the ground right here. This has to be your 90-degree angle, right? The ground and the tree are perpendicular. It wouldn't make sense to put 43 up here because that would not be the ground. So this is the only logical place to put 43. So that's the ground right there with the rays of the sun. It wants to know how long is the shadow of the tree. So it wants to know that right there. Okay, so from my angle that I am given, this is my opposite side. This is my adjacent side. Okay, so I'm going to pause here. Take a second, set up your equation, see if you can figure out what x is. Okay, you want to think about what trig function should you use, set it up, and then figure out how to get your x by itself. Okay, so let's see how you did. You're going to need to use tangent since you have opposite and adjacent. Remember, tangent never uses the hypotenuse. So tangent of 43 degrees equals my opposite side, which is 109, over my adjacent side, which we called x. Okay, now, just because I have a 109 here does not mean I can multiply or divide by 109. That will algebraically not be correct. The only thing you can ever do with the fraction is get rid of the denominator. Okay, so multiply by x on both sides. You can also set up a proportion if that helps. It's just going to force you to do the same thing. Okay, 1 times 109 is 109. X times tangent of 43 is x tangent of 43. Okay, notice that I multiply both sides by x, which is why it's x tangent of 43. Okay, I did not get x by itself, but I did undo the fraction, which now allows me to divide by tangent of 43 and tangent of 43. Okay, so I can do 109 divided by tangent of 43 and check to see that you got 116. So, the shadow is about 116.89. And there we go. Okay. Just so you guys know, again, you have options. If this is 43, we know then that this angle has to be 47. Okay, which means I can set up not a totally different, but a different equation. If I use that angle, then this becomes my opposite, and this becomes my adjacent. So I'm still using tangent since I don't have my hypotenuse, but then I can say the tangent of 47 equals my opposite side, which I called x, over my adjacent side, which I called 109. Okay, and now I can multiply both sides by 109. So notice if I do 109 times the tangent of 47, I get the exact same answer. So over here I did 109 divided by the tangent of 43, and over here I did 109 times the tangent of 47. So notice those were complementary angles, but it gives me the same answer. Okay? Alright, so that was a pretty quick lesson. Your homework is worksheet number 3, so you can show these sub your notes filled out, and they'll give you the homework. A lot of the same thing. You're setting up these 6 trig ratios, so sine, cosine, tangent, cosecant, secant, cotangent. And then it's going to be a lot of just finding missing things. So find all the missing sides and angles, setting up, instead of giving it a diagram, can you do it based off of what you're told you have? Same thing here. And then the back side is just a lot of, again, finding missing sides and angles. Okay? In each problem, you should see that you're using different trig functions. So you should use sine, cosine, tangent. You should have multiplication and division used throughout. All right? Great. Thank you.